Greetings, intellectuals. We continue our revision. Today we'll look at question B of the 2020-2021 exam edition. This document is in the 2022 tutorial sheet. You'll be able to find this information. So question B reads, the data below shows pharmacokinetic parameters of two similar Nrtis. Okay. We have varying pharmacokinetic parameters such as bioavailability, half-life, and protein bound. The questions read, show structures of the two drugs. So the drugs in question are lamivudine and emitristabine. So for the first drug, lamivudine, we draw it first by showing the base. So this right here, that base is what we draw first. This base here is cytosine. So we begin by drawing cytosine, and then at carbon 1, at 1 here, this nitrogen here, we attach a sugar. So this 2 prime, so we start counting 1 prime here, 2, 3 prime, and then 4 prime. 5 prime is on there. So for this sugar, it's a 2 prime 3 prime dideoxy. Yes, which has a thiol group at position 3 prime. Yes. So this is lamivudine structure. The only structural difference between lamivudine and emitristabine, as we can see, is the fluorine attachment on cytosine. Yes, so we can simply draw lamivudine by drawing cytosine and attaching a dideoxy sugar. Yes, with sulfur on 3 prime position. So we can note the structure. Of course, emitristabine and lamivudine have structural similarities. We can look at the base. They use a similar base, cytosine. Yes, and the dideoxy sugar is similar. It has a similar substituent on 3 prime, which is thiol. Okay, so those are the structures of lamivudine and the emitristabine. Question 2, what are the actual semisystematic names of these drugs? So lamivudine, semisystematic name, I will give it 2 prime 3 prime dideoxy thiocitidine, which is here. So that is lamivudine. Of course, we can pinpoint where the 2 prime 3 prime dideoxy is coming from. That is coming from our sugar. Our sugar is a 2 prime 3 prime dideoxy. Okay, and then the 3 prime thiol. The 3 prime thiol is extracted from this substituent at 3 prime position, the sulfur group. So that is the 3 prime thiol. And then lastly, the cytidine is the sugar and the base. So the base in question here is cytosine. So cytosine plus the dideoxy sugar, this gives us cytidine. Okay. Emitristabine, on the other hand, can be known as 2 prime 3 prime dideoxy 5-fluoro 3 prime thiocitidine. Okay, so the 2 prime 3 prime dideoxy can be attributed to the sugar once more. Okay, so the sugars are usually dideoxy in these drugs. Yes, for them to carry out their mechanism of action, they have to lack that 3 prime hydroxyl. Okay, so the dideoxy comes from this sugar as well. Then the 5-fluoro, this part of the name here. So this part of the name here is stemming from this fluorine at 1, 2, 3, 4, 5th position here. Yes, that is where it's stemming from. So 5-fluorothiacytidine, of which the thia is the sulfur in the sugar, cytidine being the sugar and the nitrogenous base. Okay, those are our semi-systematic names. Question 3. Give a brief structure-activity relationship of the two drugs. So the drugs need a nucleoside backbone for activity. So the nucleoside backbone, this component here, the nucleoside backbone is the combination of the sugar and the base, of which lamivudine has that component, even amitriptyline has that component. So the combination of a nitrogenous base and the sugar, that is our nucleoside backbone. 3', 2' dideoxy sugar is essential for activity. All DNA drugs have. So the 2', okay, so you can count our carbons on the sugar. The 1', 2', 3'. So where sulfur is, that's our 3'. Okay, so from 2 to 3', we have a dideoxy, so we lack oxygens at 2' and 3' positions of our sugar. So such a sugar is essential for activity because it helps in the mechanism of action of these drugs. Carbon 5 can be substituted on the base with a halogen. So a halogen can be added on the base to improve hydrophobicity and for pharmacokinetic purposes. So like in the case of amitriptyline, a fluorine atom has been introduced in the base structure. This is making this slightly more hydrophobic than lamivudine, which will improve various pharmacokinetics. Okay, then amitriptyline has a longer half-life, increased bioavailability due to the 5-fluoro group. So addition of a halogen on that base will increase those pharmacokinetic parameters. So we have been asked on the 4th question to look at the structural reason for the observed pharmacokinetic difference. Okay, so according to our observation, the structural reason is our 5-fluoro functional group on amitriptyline. So this fluorine atom is increasing the hydrophobic profile of amitriptyline. Okay, so that means that the amitriptyline will have improved pharmacokinetics as compared to lamivudine. So the answer is on question 4, presence of 5-fluoro group on the structure of amitriptyline improves the pharmacokinetic profile. Yes, so the structural reason for the observed pharmacokinetic differences can be attributed to the 5-fluoro functional group on amitriptyline, which we do not have on lamivudine. All right, so question 5, which is the last but not the least. What does the notation M184V mean? And what implication does this have? So according to the definition of all mutations, we'll define this mutation as a point mutation at point 184 where methionine is replaced with valine on the reverse transcriptase enzyme. Okay, what does this imply? This implies loss of antiviral activity for lamivudine, which is 3-TC, amitriptyline, FTC, and abacavir, ABV. Thank you very much for your attention. Shalom.